Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition question. This is the third question of 2025 F equals MA exam. This question is related to question 2. So we have three identical disks that are placed on a frictionless table. So initially, two of the disks, 1 and 2, are at rest and in contact with each other. The third disk is launched with speed v directly toward the midpoint of the two stationary disks along a path perpendicular to the line connecting their centers, as shown in the figure. So we assume all interactions are perfectly elastic when the disks collide, and there's no friction or inelastic energy loss. In this question, we assume there's a little imperfection in disk initial alignment, so disk 3 will not collide with disk 1 and 2 at the same time. Rather, as we can see here, 3 will collide with 1 first and then collide with disk 2. So now we want to find out what is the final speed of the disk 3. So before we try to find out the final speed, let's give a very useful tip here. So for example, we have two identical disks, 1 and 2. One is collide into disk 2 at the initial speed v. The direction of the v is along the direction that connect the two centers of the disk. So everything is elastic without the energy loss. So after the collision, as we all know that, then disk 1, the speed will become 0, but disk 2 will gain the speed of v. So this is a very useful tip. Now let's look at the first collision between disk 3 and disk 1. So let's draw the figures here. As we will know, disk 2 is not involved in the first collision. So we draw in the broken line here. So we only look at disk 3 and disk 1. So as we can see, when they collide, the force is along this direction and from a 30-degree angle with a horizontal direction. So as the tip here suggests, this v, this speed, initial speed, v is projected along that direction to be square root of 3 over 2v. This 3 will pass this speed to disk 1, so then disk 1 will go away along that direction. And then this speed component of these 3 will become 0. So the only surviving speed of these 3 after the collision with 1 will be perpendicular to this direction, which is a v cosine 60 degree, which is v over 2. So this is the remaining speed of these 3 after collision with disk 1. Now let's look at the second collision between the disk 3 and disk 2. So as we mentioned a moment ago, that's the remaining speed of disk 3, v over 2. Again, based on the tip here, the speed component that is along the direction between the two centers will the speed will pass from disk 3 to disk 2. So this is a v over 2 cosine 30 degree. This speed component will be given to these two. So the remaining speed for these three will be v over 2 sine 30 degree, which is v over 4. So after collision with these two, these three will go along this direction at a speed of v over 4. This is answer C. Thank you for viewing. If you like my video, please comment, like, and subscribe.